Welcome back from the ad break, and let's continue with our lesson. So now we are going to be moving into that first concept of our concept map, and that is writing algebraically. So we are now going to be focusing on that algebraic language. But before we can identify the conventions of writing algebra, we need to know how to identify all the components that make up an algebraic expression. Let's see. So here we have been given an expression and we are asked to label the following expression. So we have been given 3x squared, and from this expression we need to label that 3 and the x and that 2. Let's start with the 2. What do you think that 2 is? Yes, if you are thinking of an exponent, then you are absolutely correct. We know that that 2 is an exponent. What about the x? Are you thinking of a variable? Yes, you are correct. That is our variable in this expression. It is also the base to that exponent there. What about that 3? Are you thinking of a coefficient? Then yes, you are correct. So we have our coefficient, our variable, and of course our exponent. Now, let's look at converting word sums to algebraic expressions. So we know that we have been working with algebraic expressions, or we have been working with how to convert those word sums into formulas. So let's see which points we need to keep in mind when we are converting the word sums into algebraic expressions. So firstly, in algebra, we use variables to represent a certain number of which we do not know the value of yet. So when we use variables, it's to represent any number. It's just that at that moment, we do not know the value of that number yet. Then the minus operation can be used to represent words such as difference or subtract. The plus operation is used to represent words such as sum or addition. Divide can be represented by words such as share. So let's look at examples. So let's look at the examples, how we can keep these points in mind when we are converting those word sums into the expressions. So our example here that we have been given is a number is added to 6. So a number is added to 6. How can we represent that into an algebraic expression? Yes, 6 plus x. Well, we already know that added means we are going to be plussing, or we are going to be adding what we are talking about here. And of course, what are we adding? We are adding a certain number. Now remember, we said we use variables to represent numbers that we do not know the value of yet. So when we say a number, that means we can use our variable to represent that number. So we can see that that number is being added to 6, and that's why our expression is 6 plus x. The second example that we are given here is the sum of 2 and a number is multiplied by 4. So do we know what operation we are going to use if the statement says the sum? Well, if you are thinking of a plus, then you are correct. But what are we going to be adding here? We are going to be adding 2 and a number. So we already know that the value of 2 is 2, of course. And what are we going to use in place of a number? Well, since we do not know the value of that number, we are going to be using an x. And of course, the result of that is going to be multiplied by 4. So what is that algebraic expression going to look like? Well, we are going to add 2 and this number. So you can say x plus 2, or you can say 2 plus x. Remember, addition is commutative. So that means that the result of x plus 2 and 2 plus x will be exactly the same. Now, after we add these two numbers, we are then going to multiply that result by 4. So we can write this as being 4 being multiplied by the sum of a number and 2. So that can be our expression there. Let's now convert or express the following statements algebraically. The first one there says subtract 7 from an unknown number. So we are subtracting 7, and where are we subtracting the 7? From an unknown number. So that is an unknown number minus 7, that is x minus 7. The next one there says multiply a number by 2 and then add 3 to the product. So we are going to multiply a number by 2, and then to that product we are going to add a 3. And that is our expression there. Let's look at more expressions. It says they subtract a 4 from an unknown number and then multiply the answer by 10. So from this unknown number, we are going to subtract a 4 and then we are going to multiply the answer by 10. So of course, we can say there that it is 10 multiplied by 4 being subtracted from an unknown number. The next one there says multiply an unknown number by 8 and subtract 12 from the answer, then multiply that answer by a negative 2. So let's look at this statements step by step. So we are going to multiply an unknown number by 8. So that is going to be 8 multiplied by this unknown number. Then from that product we are going to subtract 12. So that is 8x minus 12. But we are not done, because to that answer we are going to multiply the answer by negative 2. So whatever answer that we get from multiplying the unknown number by 8 and subtracting 12, we are going to multiply that by a negative 2. And that is that statement there. Let's look at the last two statements that we are going to write algebraically. So the first one there says share a number into 10, subtract 1 from the quotient, then multiply the answer by 9. Now, do you remember what operation we are going to use when we are sharing? Of course, we are going to divide. So since as well we are sharing a number into 10, that means that this unknown number is being divided by 10. Then from that quotient, we are going to subtract 1, and then we are going to now multiply the answer by 9. So that is going to be 9 multiplied by that number, shared into 10, and we are subtracting 1. Then we have here subtract a 13 from a number. So we have a number where we are going to subtract 13, multiply by negative 6. So that means that from this answer we are going to multiply by a negative 6 and then divide the answer by 5. So whatever answer we get from this calculation, we are going to divide that answer by 5. And that is that word sum now written algebraically as an expression. Now, remember when we were working with numeric patterns, we were writing the rule for the pattern in an algebraic language. So let's remind ourselves of those numeric patterns and see how or what connection lies between those patterns that we worked with and this algebraic language that we are using now. So let's look at the following pattern, 3, 5, and 7. Now, can we describe this pattern in words? Yes, of course, we are adding 2 to the previous term. Now, can we describe the rule in words? Now, remember the rule, we need to make sure that we include the position of the term and the constant difference. So remember our constant difference here is a 2. That constant difference is a 2. So it's a positive 2. Now how can we describe that rule in words? Well, firstly, we know that we are going to multiply the position, which is the term number, by 2, and we are multiplying the term number by 2 because that is the constant difference. But after we multiply that term number by 2, remember we need to find that constant. Now, do we know what that constant is going to be? What do we get when we multiply 2 with 1, which is going to be for the first position? Of course, we get 2. But how do we move from 2 to 3? Yes, we are going to add 1. So we can see there that the rule is to multiply the term number by 2 and then add 1. So we're going to add 1 to that product. So let's now determine, let's just write that question properly so that our next question can show. So of course we are multiplying the term number by 2, and then we are adding 1 to that product. Right, our next question there says, determine the rule in algebraic form. Now, since as well we've already described that rule in words, we can just now go ahead and write it algebraically, and that is to multiply the term number by 2, and of course we are going to add 1. And of course we can see that it will work for the second term and for the third term, because if we substitute 2 in the place of that n, then we can see that after we add 1, then our answer is going to give us a 5, which of course is that second term. Then the last question there says, identify the variable and a constant in that rule. So as we are looking at our rule there in algebraic form, which one is the variable? Yes, the variable is the n. And which one is the constant? Yes, the constant is the 1. So we can see there that the constant there is the 1. Let's continue with our algebraic language. So when an algebraic expression is presented, we make sure that the terms are arranged in descending order of powers. In descending order of powers. Now we remember a power is a base and an exponent. So we need to make sure that those exponents are in descending order. Let's look at this example here. So we have been given an expression of 3x squared plus 7x exponent 4 minus 5x cubed plus 15x minus 4. Now for us to write this algebraic expression correctly, we need to arrange it in descending order of powers. So this expression would then be arranged as, yes, we are going to start with the exponent that has the higher value. So we're going to start with 7x exponent 4, then minus 5x cubed plus the 3x squared plus the 15 minus the 4. And that is how we would arrange our algebraic expression in the correct order or in descending order of powers. So now let's look at the next expression that we have been given. We are going to arrange this expression in descending order of powers, and then we are going to answer the questions that are below. So we have been given the 18y cubed minus 7y exponent 5 plus 2y minus 10 plus 3y exponent 4. So let's first arrange it in a descending order of powers. Can we see which one is the highest power, or highest power that has the highest exponent? Yes, we have the negative 7y exponent 5. Then the one that follows, yes, is the 3y exponent 4. Then we have the positive 18, so we are adding that 18y cubed. Then we have the 2y. And lastly, we have our constant, which is the negative 10. So make sure that the number of terms that we had there are the same. So how many terms do we have in this expression? Of course, we have 1, 2, 3, 4, and 5. Remember that those plus and minus are the ones that separate our terms. So here we have 5 terms. What about, let's look at the second question. What is the value of the constant? Did you identify the constant in our terms? Yes, of course, our constant there is our negative 10. Let's look at the next question there. It says, what is the exponent value of the variable of the fourth term? So now we first have to identify that fourth term and then look for the exponent value of the variable of that fourth term. So we have the first term as negative 7y exponent 5, the second term as 3y exponent 4, the third term as 18y exponent 3, and the fourth term is 2y. So what is the value of the exponent for that variable? So as we can see, the variable there is the y, and yes, the exponent there is a 1. So the exponent there is a 1. Then lastly, we are going to look at what is the coefficient of the third term. So we've already seen that the third term there is 18y cubed. So what is the coefficient of this third term? Well, yes, it is a positive 18. That is the coefficient of that third term. Let's quickly go to an ad break and then we'll see you just now.